Now comes on the next topic, the free vibration, post vibration, damped vibration and resonance. Free vibration किसको कहते हैं? When a particle or a body is oscillate and the body oscillate the to and fro motion about their mean position and continue to oscillate, their frequency is called natural frequency and the vibration is called free vibration. Damped vibration किसको कहते हैं? When a body or particle oscillates from the mean position due to some external resistive forces, the oscillations of the particle or body slowly dies out and comes to rest in the mean position. This vibration is called damped vibration. Forced vibration किसको कहते हैं? When the particle or body oscillates by applying the periodical force. When force is applied and this body oscillates on the applied force, that is, the amplitude of their oscillation becomes large. Their frequency is different from the natural frequency of the body, is called forced vibration. Resonance किसको कहते हैं? When the body oscillates in a free vibration and at a certain stage the natural frequency of the body becomes equal to the frequency of the applied force, the situation is that their oscillation will be maximum, that is the amplitude maximum. The condition is called resonant frequency and the phenomenon is called resonance. Now about the definition and apart from the definition of the free, forced, damped, resonance, vibration, the detailed and analytical treatment also studied, such as damped vibration. In case of damped vibration, the analytical treatment of damped vibration. So damped vibration के केस में आप डिटेल एनालिसिस, what was the question about that? What was the question? What is damping? Obtain an expression for the displacement in the case of damped oscillatory motion. Discuss the effect of damping vibration on the natural frequency. Supposed, आंसर में आप देंगे सबसे पहले, suppose that a body of mass m is vibrating under a spring force of constant s called a stiffness constant, and the y be the displacement of the body from the mean position. The forces acting on the body executing damped vibrations are: first, the restoring force, which is proportional to the displacement y but in opposite direction, given by minus sy, and second, the retarding or damping or frictional force proportional to the velocity dy upon dt but opposite in the direction of the motion and is given by minus mu dy upon dt. This is the restoring force, this is the retarding force. These two forces act, hence the resultant force F is equal to minus sy minus mu dy बटे dt Now since force is equal to mass into acceleration, and acceleration in differential form d square y upon dt square, therefore m d square y बटा dt square plus sy plus mu dy upon dt is equal to 0, and d square y upon dt square plus s बटा m y plus mu बटा m dy बटा dt is equal to 0. So putting the constant d square y upon dt square plus this mu by m is 2k dy upon dt plus s by m is omega square y equal to 0. This is the equation and differential equation. To discuss the differential equation, let us consider the solution, the particular solution and the differential solution. The particular solution of this equation will be y is equal to a e to the power alpha t. The particular of y is equal to a e to the power alpha t, where alpha a alpha constant. Now this is differentiated twice to put on the value. So dy upon dt is equal to alpha a e to the power alpha t, and d square y upon dt square is equal to alpha square a square e to the power alpha t. This is the value putting on this. So d square y के जगह alpha square a square e to the power alpha t plus 2k dy by dt a e alpha t plus omega square y की जगह पर हो गया a e to the power alpha t is equal to 0. This is the equation. Now using the boundary condition y is equal to y naught. Using the boundary condition y is equal to y naught and maximum, and dy upon dt is equal to 0 when t is equal to 0. The result will be finally obtained is y is equal to y naught 1 by 2 1 plus k upon root over k square minus omega square exponential minus k plus k square minus omega square into t plus 1 by 2 1 minus k बटे k square minus omega square exponential e to the power minus k square omega square t. So y is equal to y naught 1 बटा 2 plus k upon root over k square minus omega square exponential minus k plus k square minus omega square into t and plus 1 upon 2 k upon minus 1 माइनस, तो इधर हो गया 1 प्लस, तो इधर हो जाएगा 1 by 2 1 माइनस k अपॉन रूट ओवर k स्क्वायर माइनस ओमेगा स्क्वायर एक्सपोनेंशियल माइनस k माइनस रूट ओवर k स्क्वायर माइनस ओमेगा स्क्वायर इंटू t. This is the equation. Now the condition cases 1, 2, 3. Third cases, three cases. First, k square is greater than omega square. This is the condition of the overdamped periodic or deadbeat condition. K square is equal to omega square. This is the condition of the critical damping or non-oscillatory. And third, k square is less than omega square. This is the condition of underdamped. The time period t is equal to 2 pi root over omega square minus k square.